Why is frequency spectrum important in analog signal processing? Imagine trying to listen to your favorite song but with some parts muffled or distorted. That's where understanding the frequency spectrum becomes essential. It's like having a map of all the different pitches and tones in a signal. When engineers analyze this map, they see how the energy or information spreads across various frequencies. This helps them figure out how to process signals better. In analog signal processing, signals are continuous in time and can contain many different frequencies at once. By studying the frequency spectrum, engineers can identify which parts of a signal are useful and which are noise. For example, they use filters like low-pass filters to block high frequencies or high-pass filters to cut out low frequencies. This way, they can clean up signals and improve quality. Modulation techniques relying heavily on the frequency spectrum. When sending signals over long distances, they shift the signal's frequency content to different bands. This makes transmission more efficient and reduces interference with other signals. For instance, amplitude modulation changes the amplitude of a carrier wave based on the information signal, and understanding the spectrum helps in designing these systems. Amplifiers and processing circuits also depend on the frequency spectrum. They are designed to handle specific frequency ranges to avoid distortion and maintain fidelity. If a circuit is tuned to the right frequencies, it can amplify the desired signals without adding unwanted noise. Frequency spectrum analysis also helps in managing bandwidth. Bandwidth is the range of frequencies a system can process or transmit. Proper bandwidth allocation prevents signals from overlapping, which can cause interference. This is especially important in radio frequency applications where many signals share the same space. In analog modulation, the frequency spectrum shows how the carrier and information signals combine. This understanding helps engineers design modulators and demodulators that accurately encode and decode information. It also guides the design of analog filters like finite impulse response filters, which shape signals directly in the frequency domain. These filters are useful in reducing power consumption and complexity in radio front-end systems. To sum up, the frequency spectrum is vital because it helps in analyzing, designing, and improving systems that process continuous signals. It ensures signals are transmitted clearly, filtered properly, and received accurately. Without it, managing signals in the real world would be much more difficult.